Hi, this is a short tutorial on algorithmic trading from Tertiary Courses. In this video, we will show you how to code a Lstm long strategy for algorithmic trading. This is not meant to be a correct way to implement Lstm for algorithmic trading. It is an experiment. So feel free to comment on the experiment and how we can further improve on the strategy. First, we will load all the necessary Python packages. We will use the Yahoo Finance package to import the historical data. In this example, we will import the Microsoft dataset for backtesting. Next, we will visualize the time series of the adjusted close. Apparently, this is a highly non-stationary time series, right? Next, we will compute the returns using this formula and define the target. If the returns in the next day is positive, then we will take a long position. If we don't have any stock, we will buy some stocks. If the return in the next day is negative, we will take no position. So if we are holding some stocks, we will sell away all the stocks and hold no position. Next, we will try to scale the data for the Lstm. However, since the time series is non-stationary, we decide to do a rolling scaling of 2 months. We extract the highest and lowest stock price in the 2 months of trading days, then we scale the data. I know this is a very controversial approach. Let us see whether this approach will work or not. After that, we count the number of days, taking the long positions and no positions. It is about 50% each. Next, we define a sliding window to form the XY pair for the Lstm trading. The inputs are the open, high, low, and adjusted close. If you want, you can include the volume, and we did not include the volume for simplicity's sake. Next, we will use 20 days to form the XY pair for the trading. Next, we will split the time series into training and testing data set. We arbitrarily take 70% of the data for training and 30% of the data for testing. Next, we define our Lstm model. You can use a very simple 1-layer Lstm followed by a dense layer with 1 unit of sigmoid, and that will produce an output from 0 to 1. Or you can use a more complicated Lstm model with few layers stacked together, or you can even try out the bidirectional Lstm model. We have tried all the 3 models and we don't find any significant difference in the performance. So for this tutorial, we will just demonstrate the stacked Lstm model. So we choose Adam for our optimizer and the binary cross entropy as a loss function. You can choose the mean square error. It doesn't make much difference. One thing to take note is that for LSTM, it is advisable to choose a slightly lower learning rate. Next, we will train our models. In this case, we train for 300 epochs with a batch size of 32. It takes about 5 minutes to finish the model. Next, we will plot the loss versus the epochs. You can see the model is able to learn from the training data as the loss is reduces with the epoch. Next, we compute the accuracy, which is about 52%, and we also compare the test label and the prediction. You can see that the prediction is much smaller than the test label, and we verified this using the confusion matrix and also the classification report. Right, you can see that the recall for the zero label is very low. Next, we'll do some trade analytics. We compute the signal as a model prediction, and we also compute the strategy returns using this simple formula. Next, we compute the trades. So zero means there's no trading. 1, we buy the stock, and -1, we sell the stock. We count the number of 0, -1, and 1. You can see that there are very few trades. Okay, there are 53 trades that are selling and 53 trades that is buying. Next, we plot the histogram of the strategy returns and also overlay the buy and sell on the stock price. Again, you can see that most of the trades happen on the training data. There's hardly any trades on the testing data since 2017. So after 2017, this model practically just hold the stocks. That explains why the strategy returns is very similar to the buy and hold return. Finally, we compute the list of metrics for the strategy using the bifolio. We got a Sharpe ratio of 0.55, which is bad, and the maximum drawdown of -57%. Anyway, if you are happy with the model, you can save it and then use it again in the future. This is all for this experiment on LSTM for the algorithmic trading. The code is listed below. We welcome your comments below so that we can further improve on this model. Thank you very much.